Okay, so this will finish up the lecture on latent sensible heat transfer. Because there are a couple of things to get to. So this is, I went over this in class, but I'll go over it again really quickly. Remember that latent heat is when you transfer heat and it does not result in a change in temperature, but it does result in a phase change, okay? And so we talked about how going from liquid to gas, that's a phase change, right? So in order to do that, you need to add heat to um, the liquid, right? So to boil water, you keep adding heat to it, and then eventually turns into gas, right? So that's a phase change. That's latent heat transfer. And as it turns out, when the water gets to 212 and then it's actually still a liquid, and you have to add a bunch of heat to it, and it's still at 212, but it's a gas. Okay, so it turns into steam. But and very importantly, the reverse is true as well, right? So when you go from gas to a liquid, so if you add heat to the water to turn it into a gas, that heat doesn't disappear. It stays with the steam. Okay, and so then when the steam condenses back into a liquid, it releases all that heat out. Um, and that is also latent heat transfer because you're removing heat, but the steam when it condenses, it's still the same temperature. It's just liquid at that point. All right, so that's latent heat transfer, and it's really important to remember. I don't care too much about freezing and melting, but that's another phase change, and sublimation and deposition, which you definitely won't deal with over here from gas to solid. Um, but this is really, really important to keep in mind, right? So when you evaporate something, it absorbs heat. Okay, so you have to add heat to it. When something condenses, it dumps heat back out. And again, this will become really important with HVAC in particular. Okay, so I won't go over that example again, but if we kind of look at the phase change there. So it's called the latent heat of vaporization. 1 pound of water is 970 BTUs. Okay, and so in order to go from 210 to 212, you have to add 2 BTUs. But then to boil that whole pound of water, which is still at a liquid at 212, it's called superheated at that point. You have to add 970 BTUs, and that is all dumped into that steam. The steam is the same temperature as the liquid water. It has all this extra heat, all this extra heat in it. And so that's the heat that's dumped out and released when you go back from a gas down to a liquid. Okay, so that heat has to come from somewhere, and then the heat has to go somewhere when you're done with it. Okay, so remember that when something evaporates, it absorbs heat. When something condenses, it releases heat. Okay, so this leads us to basic air conditioning. We'll talk about the refrigeration cycle and how that impacts air conditioning. So if you look at this, very simplified diagram of a window unit, right? So this is a wall, and you have inside the house and outside the house, right? So it's like one of these things. Okay, so it's in the wall. You notice that when you have these window units, they go through the wall, or out the window anyway. All right, and so so the question is, this generates cold air, but where does that cold air come from? Does it take outside air and cool it down, and dump it in? And I think that's what most people think, but it turns out that is not the case. What actually happens is it takes warm air from inside the building. Notice we're still inside here. Warm air from inside the building, and it cools that down. And that's the air. So the air, if you put your hand against this, the vent here, right, you'll feel the cold air coming out. And a lot of people think that's coming from outside, but it's not. That's recirculated air coming from in the building. It's recirculated up here, and all it is, there's a little fan in here that blows that air across cold coils. So there's some coils in there that are cold, okay, and that's where that cold air comes from. So, but think about the thermodynamics here. Okay, so we have warm air, and we have cold air. So there's heat here that must have gone somewhere. So the question is, where does the heat go from this airstream? And the heat actually is released out of the back of the unit. Okay, so the back of the unit, which looks like this, and if you've ever seen the back of a window AC unit, has these tubing with some fins, some metal fins on it. And so this whole process is the refrigeration cycle. So it's actually latent heat transfer, right? So again, to sort of take the basic thermodynamics, we take heat, so heat from this air, and somehow we get it, dump it out this way, but we hold on to the air itself, and then we blow that cold air out. Okay, so this air stream doesn't change, but the heat is somehow removed and dumped out. And so that is all about latent heat transfer. Okay, so let's take a look at this. So this is this is a simplified version of this, and there was a video posted about this. So feel free to look at that. But this whole thing runs on the compressor. Okay, so you have a compressor, condenser, expansion valve, and evaporator. Okay, so those are your four really big main components of the refrigeration cycle, and so like a refrigerator, a freezer, an air conditioner, and so forth. Okay, so we'll start at the compressor. So the compressor, as the name implies, compresses some gas. And so if you see on this, what I like about this diagram is that the color coding indicates the general temperature trend throughout this process, right? So this is a cool gas, okay, light blue, it's cool. And then when you compress a gas, and you may know this, compress a gas, it heats up. And so that's all the compressor does, is it heats it up, and then you have a hot gas. Okay, so there's a hot gas over here under high pressure, because this pressurizes it. The compressor pressurizes it, which causes it to heat up. So then you have a hot gas that goes to the condenser, and guess what happens in the condenser? It condenses, right? And so remember, when you condense, you release heat. Okay, so that's why this arrow is red. This condenser's dumping heat out. The condenser is literally just tubing like this and coils. That's it. It's a passive component. There's no mechanisms in there that like move around. It just sits there, and the refrigerant, which is what's inside of these loops, right? So this is a closed loop with refrigerant inside. The refrigerant just dumps heat out because it condenses from a vapor to a liquid here. So now we have a warm liquid, okay, a warm liquid refrigerant. Comes through here, it's the expansion valve, and guess what the expansion valve does? It expands, or it doesn't expand, but it it goes from a smaller to a bigger. And so what that does is that drops the pressure, right? So we had high pressure here from the compressor. This is all pressurized. And then it hits the expansion valve, and this is the low side, okay? So low pressure side, or the low side. So low pressure, very cold liquid now, okay? And then we have our liquid that goes through the evaporator, and you probably can guess what happens in the evaporator. It evaporates. So remember, when it evaporates, it pulls heat in. So remember, how do you boil water? You add heat to it, excuse me. And so in the evaporator, it pulls heat from the air around the coils. Again, it's the same type of coils as the condenser. But in this case, we have to absorb heat from around the coils. And what does that do? It makes it cold, right? We're pulling heat out of the air, putting it into this liquid. So what that does is it makes it cold, then you blow a fan across it, and that's how you generate cold air in an air conditioner or a refrigerator or heat pump. And then you're back to your cool gas. Then you compress, put under high pressure. That dumps heat out, drops the pressure and temperature, absorbs heat here. So really, it's essentially what it's doing is it's taking heat from here and taking heat from here and dumping it out here, and taking more heat from here, dumping it out here. So that's why, it's not converting energy directly to heat. It's actually taking heat from one location and dumping it in the next, right? And that's this whole, and that's what happens here, right? So what you do is you run these across those coils. It takes heat out of that air and dumps it here. Takes heat out, dumps it. Takes heat out, dumps it. Okay, so that's how the basics of how an AC unit refrigeration cycle works. So that is how, as I said, refrigerators work, air conditioners work, water fountains that keep the water cold, the air conditioning in your car. It's all uses that refrigeration cycle, and it's all about latent heat transfer. So it uses the latent heat process to take heat from one location and dump it into the other. And that's really all that those do, those pieces of equipment do. Okay, so now you should have, from before, a decent idea of the different temperature scales, and that Kelvin is at 0 Kelvin is absolute zero, which is the lack of molecular motion. Look at the boiling and freezing points of water, and absolute zero, as I said. And then sensible and latent heat, very, very important concept. We will revisit that moving forward. So try to wrap your mind around it, and then we'll have more opportunity to sort of investigate that concept moving forward, and certainly some of the applications for it. And then the vapor compression and refrigeration cycle. That's really important to understand, like those four main components and the basic process. Okay, so that's it for this lecture.